Assalamu alaikum. In today's lecture, we will discuss the estimation and confidence interval. Uh, and we are heavily relying on the concepts of previous chapter. So let's have a brief recap of the previous lecture. In previous lecture, we have described what is the central limit theorem and the sampling distribution of sample mean when sigma is known. So the central limit theorem states that the larger random samples, the shape of sampling distribution of mean is close to the normal distribution. So this is the concept of central limit theorem when we have a larger n samples. The shape of a curve or a sampling distribution will close to the normal probability distribution. So let's move on to the next slide and we will see that what are the goals for this chapter. First, we will define the point estimate and the level of confidence. Then we will see how the confidence interval will be construct for the population when the standard deviation is known or when the standard deviation is unknown. And then we will see how we will construct the confidence interval for population proportion and how we can determine the sample size for attribute and variable sampling. So let's move on and see how we can define that these terminologies. So the first one is point estimate. The point estimate is referred as the exact value or a single value that of population parameter of interest. So this statistic is basically X bar, or you can say the sample statistic, computed from the sample information. So when we have a sample information, we can calculate the x bar. The x bar is equal to summation of x divided by n. So this is a very well known formula for you guys. So this x is basically all possible values of x, or you can say the observations, and then we will find out the this statistic. And this statistic is basically the representative of population parameter, or we can estimate the population parameter based on this information. If we can say that x bar is equal to mu, mu is basically the population parameter. If these two are equal, it means that this x bar is a true representative or an unbiased representative of this population. The difference between these two uh, operators is the error. So the next definition is the confidence interval estimate. So if we break this definition into two parts, the first one is interval and the second one is the confidence level. So this interval is basically the range of values constructed from sample data. So we will construct a range of values from sample data, and then we will assign the probability for that interval, and we will assume or we will see that it will include the true value of population parameter. So this terminology basically have two parts. The first one is the range and the second one is the probability, which is called the level of confidence. So by using the confidence interval estimate, we will be able to find out the range of values uh, from the sample data, and we will assign the probability that these values include the population parameter. So let's move on to the next slide. So there are some factors which affects the confidence interval estimate. So the first one is sample size n. If we have a large n, we have a small standard error. Or when we have a small n, the standard error will be larger. We can write this expression in that form. This is large n and this is small n. The variability in the population usually sigma estimated by S if sigma unknown. So the variability in the population is also have its importance, and when we have a large population standard deviation, so the standard error will be larger as well. Or if we have a smaller population standard deviation, the standard error will be small as well. The standard error have its formula where the sigma base x bar is equal to sigma divided by under the root n. So this terminology is called standard error. So when we have a larger population standard deviation, have a larger standard error. If we have a small population standard deviation, the standard error will be smaller. The desired level of confidence or the probability. So the third factor which can affect the confidence interval is the level of confidence. So we have in this chapter, we have discussed the two level of confidence, which is 95% and 99% for Z. For the 95%, we have a value of 1.96, and this is the 2.585. If you remember the rule of normal rule or empirical rule, which we have discussed in previous lecture and in chapter 2 as well. So when we have two standard deviation, there will be a 95% of observation will be lie under the 90 under the curve, and if we have a three standard deviation, so we will assume that practically all values are lie under the curve in a given percentage. So if we round about these values, we will get this these standard deviation of the mean, two standard deviation and three standard deviation, and we have uh, a 95% of probability, or we can say that we are 95% confident on that particular situation that we will get the favorable result, and there is a 5% chance for unfavorable results. So this 5% is basically called level of significance, which is denoted by alpha. When we divide this alpha into two tail, so this 5% is divided into 2.5%. So if I draw a curve here and I say there is two-tailed test, we will discuss it further that what is two-tailed test. Two-tailed test, we can say that the 0.025 alpha will be here and 0.025 alpha will be here. So it will be distributed on the both side of the curve. So this is the alpha values. We will also draw the z values on the on this graph as well. So if we say that we have 95% of confidence interval, so the z value of minus 1.96 will be plotted here, plus 1.96 will be plotted at positive side. So let's move on to the next slide. So this is the interval estimate interpretation, how we can interpret the interval estimates. So in this example, we have 95% of confidence interval of the similar constructed interval will contain the parameter being estimated. So we can say that the given sample is containing the population parameter. So there are 6 samples given. There are 5 sample which contains the population parameter at some point in the given sample, but only the sample number 5 does not contain the population parameter. So the sample size will be lie within 1.96 standard deviation of hypothesized population. So they are so this diagram is only showing that the uh, population have a different sample mean. So let's move on to the next slide. So let's see what are the characteristic for T distribution. It is like Z distribution. T is almost like a Z distribution and a continuous distribution. It has a bell-shaped curve and symmetrical. If I draw a Z distribution, let me draw it again. That doesn't look like a curve. So we can say that this is a T distribution. It is symmetrical and bell-shaped. There is not one T distribution, but rather a family of T distribution. All T distribution has a mean of 0, but their standard deviation differ according to the sample size of n. In Z distribution, we have a mean is equal to 0 and standard deviation is equal to 1. But in T distribution, mean is 0, but standard deviation is not known or unknown. But we can say that when n increases, the curve will be close to the normal distribution. Okay. So here if I draw the Z distribution, so we will find out that what is the difference between Z and T. So this is the curve for Z distribution. So you can see the difference between these two curves. T distribution has a flatter at the center and Z distribution have a higher peak. So the sample size increases, this curve will be move above and it will approach to the standard normal distribution. However, t distribution approaches to the normal distribution when n increases. So this is the main difference between z distribution and t distribution. Z is a higher peak. On the other hand, T has a flatter at the center and it is more spread out as compared to Z test. So let's move on to the next slide. So here we are comparing the Z distribution and T distribution when n is small. So when we have a smaller n, you can see that Z has a higher peak and T has a flatter peak. So in a given confidence interval, which is 95% and alpha is on two tail, which is divided into 2.5, or you can say that 0.025 on both sides. So this is the graphical illustration for Z and T distribution when n is small. So here is the formula for the interval estimate for Z and T. So when we will use Z, if the population standard deviation is known or the sample is greater than 30, sigma is known and n is greater than 30. So we will use Z distribution. If we have sigma unknown, and n is less than 30, we will use T distribution. And we will put the values of confidence interval according to the given information. So this will be x bar mean, sample mean, z is z distribution. We will see the value from the table for this or a confidence interval. This is the standard deviation and this is the number of observations under the table. Or you can say that this terminology is basically standard error. So these two formula have one difference. If we have n is less than 30 and sigma is unknown, we will replace z with t and we will use the uh, s notation for the standard deviation instead of sigma. Let's move on to the next slide. So here we are going to see when to use the z or t distribution for the confidence interval computation. So we already discussed when we will use Z and when we will use T. So let's see this flowchart diagram. Assume the population is normal. We are assuming the population is normal. Then we are going to find out that if the standard deviation is given or standard deviation is known or unknown. If yes, we will use Z distribution. If no, we will use T distribution. Moving on. So here we have the confidence interval example using T distribution. So let's see what information is given for the T distribution. So the sample of 10, this is n, and then the sample mean is given, which is 0.32 inches, and the standard deviation is 0.09. So the given in the problem, this information is given n, x bar, and standard deviation. So we are using t here because n is smaller than 30. Here the sigma is known, s is known, Construct a 95% of confidence interval for the population mean. So we are going to construct the confidence interval at 95% of population mean, and we are going to find out that the the mean amount of remaining zero point zero 0.03 inches spread. So let's move on to the next slide. We will compute this information by using this formula. So since sigma is unknown, sample standard deviation was given, but population standard deviation is unknown. So we are going to find out that what are the t values, because if the sigma known, we were going to use z value. So let's see how we will compute the t value. I have described before that alpha is the level of significance, and if we are going to divide this significance level or the error level in two sides of uh, curve, it will be like this. So at the middle of the diagram, we will have a 95% of confidence. So if we can say that we are confident at 95% for the favorable results, so what else will be left? There will be 5% left for unfavorable results. So if we divide this 5% on two tails, it will be turned out 0.025 on both sides. So if you can see that in this diagram, here is 0.025 and here is 0.025. And the other thing, which is n minus 1, so we have to consider the subscript of t-test, where alpha divided by 2 and n minus 1, and we will see the table according to these two values. So here we are going to see in a table of t-test where the confidence interval is mentioned, which is 95%. Under this 95%, the level of significance for one tail is given, and then the level of significance of the two tail is given. So we are going to find out this for two tail test, which is going to be 0.05 or at the 5% level. So n is 9, 10 minus 1 will be equal to 9. So we will see the value corresponding to these two values. The first one is confidence interval, second one is n minus 1. So this value is 2.262 on both side of the diagram. This is mentioned over here. And then we will put the value, put the information which is given in the question, and we will find out the interval where the population parameter is lies. So we can conclude that the manufacturer can be reasonably sure 95% confident, or he can get the favorable results that the mean remaining thread depth is between these 2 points. So you can see that we find out the interval by using t values, or we can say that we found the probability, we found the interval based on 95% probability. So there is a 5% of chance of error. This level of significance is basically showing the chance of error. So let's move on to the next slide. So the confidence interval estimate for mean using Minitab, we can also use Minitab for this purpose. Minitab is basically a software which estimates the statistical tests like Excel or Stata. So in this example, we do not have a information for mean and standard deviation. So the sample is given, n is 20. We can find out the information by calculating the mean, where x bar is equal to summation x over n. We can also compute the standard deviation, where the under the root summation of x minus x bar whole square n divided by n. So we can find out these characteristics of this information, and then we can calculate the t-test and find out the interval of a given problem. So let me clear the drawings first and we will see what we are going to have next. So confidence interval estimate for using Minitab. This is the Minitab output for this particular problem, and this is the output from Excel. So here we are going to conclude our lecture. So in this lecture, we dis- have a discussion on t-test and z-test and their differences. What is the confidence level and the level of significance, point estimate, what are these terminologies. We had a discussion on this. So I hope that you people will be do the relevant examples. Thank you so much. Allah Hafiz.